All right, so Kepler's second law is the law of equal areas. If a line drawn from the sun to the planet sweeps equal area in equal time, um, a planet's orbital velocity changes as its position in its orbit changes. As a planet gets closer to the sun, it's going to be speeding up. As it's getting farther away from the sun, it's going to be slowing down. The best way to understand this law is simply by looking at a figure. So let's go ahead and do that. So take a look at this figure. You'll notice that there are going to be these bluish areas and these white areas. All those areas have the same area. So this area is the same as this area, as the same as this area, as the same as this area, all the way around. These areas on the right, these are just really stretched out. Okay, and what this law is saying that if I'm looking at the time that it takes the Earth to go from December to January, it has to go this entire path. If I'm looking at it from June to July, it only has to go this far. But the law tells me that it's going to take the same amount of time. The law of equal areas mean that it's going to take the same amount of time for it to go from December to January, these two positions, as it would take to go from June to July. Meaning that if this is going farther in the same amount of time, it must be going faster. So the Earth is speeding up from July all the way through to January when it's closest to the sun. And then as it whips around the sun, going through February back to July, it's going to be slowing down as it gets farther away from the sun. That is Kepler's second law. Kepler's third law states that a planet's period of revolution, the time to complete one orbit of the sun, is related mathematically to its average distance from the sun. And the best way to understand this is just looking at that equation, t squared equals r cubed. T, the planet's period in Earth years. So the period of the Earth is going to be 1. It takes 1 Earth year for Earth to go around the sun. If a planet has a T value, a period that's less than 1, it's going to mean that it's going around the sun faster. And if it has a T or a period that is greater than 1, it means that it's going to take longer than a year, an Earth year, for that planet to go around the sun. R is going to be the mean distance from the sun in astronomical units. So remember that Earth, as it goes around the sun, is going to be constantly getting closer or farther away. So it's going to be the mean value between the farthest point and its closest point. So let's take a look at the planet Mars here and see if we can practice this equation. Mars's mean distance from the sun is 1.52 astronomical units, AU. What is its period? So if we plug that into our equation, t squared equals r to the third, we're going to get t squared equals 1.52 to the third. If I raise 1.52 to the third, I'm going to end up with t squared equals 3.511808. I take square root of both sides. I end up with t of 1.87 Earth years. What does that mean? If you want to put it in better terms, what we can do is we can multiply it by 365 days in a year. And we will get how many Earth days it takes for that planet to go around the sun. So what we figured out is that it takes 684 days for Mars to go around the sun, to create one complete orbit. So your homework, you have 2 assignments as usual. You're going to be completing a Kepler's Law Google Form worksheet. So that is going to be based on what we talked about during this video. Make sure you complete that through Google Forms and you get that turned in. And then you're going to be doing a guided activity in your Cornell notebook. Make sure that you submit an image of your work to Google Classroom. There are specific instructions on how to do that. You can't just upload the picture to the assignment. You have to upload it to your drive and then attach it to the assignment from your drive. So make sure you read the instructions on both of those all the way through. And of course, you can always come in to my student support every day, check those times.